Hey everyone, welcome back to Swift Fundamentals. Today we're going over classes, structs, and enums, three key data structures in Swift. By the end of this, you'll know when to use each and understand the differences between value types and reference types. Let's go ahead and dive on in. I'm working in a blank playground file, but of course feel free to apply these to any of your projects. But first, let's go ahead and take a look at classes. Classes are reference types, which means they're shared between instances, and changes in one instance can impact others. Classes are perfect for data that needs to be shared and modified between instances. So in order to define a class, we can go ahead and just use the class keyword, and then we'll go ahead and give it a name. You'll actually want to start your classes with a capital. Once we have our name, we can then add our brace here. We can add some variables. Let's go ahead and add a variable for this vehicle, and we'll say make, and we'll establish this to be a string. Then we can also add a variable for model, which will also be a string. And then we can actually initialize. So we'll say init, and we can even see that we do have the autofill feature here, and it's going to initialize our make. Use the self.make and the self.model. So in this example, vehicle is a class with two properties, make and model. We initialize a vehicle instance using the initializer, or that init, I-N-I-T keyword. So let's go ahead and create some instances and show the reference behavior. So since classes are reference types, we can have a car1 and car2. Let's go ahead and say let car1 equals vehicle, and then we can add the make and model. So I think last time we did Toyota Corolla, so maybe we'll do a Toyota, I think it's Camry is another one. We can even say let car2 equals car1, and car2.model equals Corolla. I'll put this in a string, sorry. It's like, why is it giving me things? And then let's go ahead and print the car1.model. So before we run this program, what do you think our print statement's going to say? Let's find out. Oh, it prints Corolla. Why is that? Well, since classes are reference types, car1 and car2 refer to the same instance. Changing car2's model to Corolla also changes car1 model because both point to the same spot in memory. All right, now let's take a look at structs. Structs are value types, meaning each instance has its own copy. Changing one instance doesn't affect the other one, like in classes. So let's go ahead and create a structure here, and we're going to actually call it car. We'll add our brace once we're happy with the name. We'll add a variable, and we'll also call this one make and model. And we'll set both of these to be string values. So here car is a struct with properties make and model. Structs are usually used for simpler data that doesn't need to be shared between instances. So let's go ahead and make some variables down here, and we'll call this one variable car A. We'll have it equals car. We can use our autofill for our make, and we'll do, what's another popular brand? Honda, and then Civic. That's a pretty popular car. And then let's go ahead and have our variable car B equals car A, and let's set our car B.model, just like we did with our classes, to be something else. So another one is the Accord. Let's go ahead and print the car A.model, and then we can also print the car B.model. So in this example, changing car B's model to Accord doesn't affect car A. This is because structs create independent copies, so modifying car B doesn't touch car A, but we saw with the classes, when we updated it, it all got changed. So with those structures, they're those independent copies. So again, modifying one doesn't affect the other. So when should you use a class versus when should you use a struct? This is something that I get asked all the time. As a general rule of thumb, use structs when you need independent copies of data and want better memory management. Use classes when you want shared modifiable data between instances. So for example, if we maybe had a user in a social media app, you would want to put this in a class. So you could have things like their username, email, profile picture, things like that be updated, any of their messages, right? For a struct, maybe this would be something would be a point in a 2D game because it's referencing a specific coordinate on the plane. It doesn't require any other interactions or adjustments there. Now let's talk about enums, which is a short form for enumerations. Long word, you can see why we use enums, but these let us define a fixed set of related values. They're great for categories or specific states. Let's go ahead and define our enum with that keyword, and we can give it a name. We'll say vehicle type. Just with your classes and your structs, you'll want to start those with a capital letter. And when we're in the enums, we're actually going to use cases. So you're going to say case car, case motorcycle. We'll add another case for maybe bicycle here. Bicycle, bicycle. It's a great Queen song. I saw them live in concert, and they were like doing the bicycles with the rings. It was really cute. Anyways, so here vehicle type has 3 properties: .car, .motorcycle, and .bicycle. Enums are perfect for handling specific cases or categories. So we can actually combine enums with structs to categorize data within our models. For example, let's add type to our car struct using vehicle type. So let's go all the way to our structure here, and we'll say bar type vehicle type. And we do get an error in our car A here when we're referencing the car. So let's go ahead and adjust this, and we'll say type dot car. All right, and let's create another version of car here just so we can see everything from the start. Let's go ahead and say let my car equals car, and then we'll have to provide all the information here. So let's do a Ford Mustang. So we'll say Ford Mustang, and then the vehicle type dot car. If this was something that's a bicycle, you can of course declare it as such. Let's go ahead and print all of this out now. Print my car is a, and then we'll go ahead and interpolate a my car dot type. So here we're actually going to reference what type it is. It's going to say my car is a car, but if we were to change this to be a bicycle, which I don't think Ford makes bicycles, but just for our example here, my car is a bicycle. Maybe you can even say my vehicle to make it a little bit more clear. My vehicle is a bicycle. So here my car is a car instance with a type set to .bicycle. Enums help keep values consistent and readable, especially for categories. So it's almost like you're presenting them with a list of values that you've picked out in order to ensure that there's consistency, readability. Even if there's something where you're creating maybe a form and you want to grab all of the bicycles, if everything is uniform, spelled the same way, right, you can access how many of them have .bicycle types, right? So you can use the enums to almost like create a consistent set of values, right? So quick recap: classes are reference types, great for shared data that needs modification. Structs are value types, ideal for independent non-shared data. And enums define a set of related values, perfect for categories or fixed states. So that's a wrap. We did classes, structs, and enums, along when to use each. So thanks for tuning in to Swift Fundamentals. If you enjoyed this, don't forget to like and subscribe for more. And until next time, dream big and code bigger. Have a great day, everyone.